Okay, so today in this video, I wanted to redeploy my OpenShift cluster and I want to change up the networking a little bit. So when you deploy OpenShift, you can choose which CNI you want to use. So for the supported CNIs in OpenShift, there's currently OpenShift SDN, there's OVN Kubernetes, and there's also Kuryr when you're deploying on top of OpenStack. So Kuryr has some benefits over the other two. Mainly, it avoids the dual encapsulation. And what I mean by that is that if you're running OVN Kubernetes and also OVN on TripleO, like we are in this environment, then we have Geneve tunnels between our hypervisors. So the Geneve tunnel encapsulates my tenant traffic to make it so that the VMs can appear as if they're on the same layer 2 network with no routing in between. And the same for older versions of OpenStack like Queens, where it was using VXLANs. It's the same concept, it's just done a little bit differently in OVN. So then what we have in OpenStack is we have that encapsulation between our hypervisors, and then maybe we run our worker nodes for OpenShift on two different hypervisors. So now the pods are also going to send their traffic over a Geneve tunnel between the two VMs, the worker VMs, but that traffic is also going over a Geneve tunnel from the hypervisor layer. So we just end up with some fairly complex networking, and it becomes more and more difficult to debug the more layers of abstraction and encapsulation you add. So the benefit of using Kuryr is that it plugs directly into Neutron. So Kuryr makes API calls to Neutron and it creates ports for your pods. It also uses the Octavia API to create load balancers. Now, in previous versions of OpenShift, it would create those load balancers using the Amphora driver for Octavia. And that was fairly prohibitive from my perspective because I only have the single hypervisor. I didn't have enough resources to run 40 load balancers plus all the VMs I would need for OpenShift. So it's never been very accessible for me in my home lab. But now Kuryr can utilize the OVN provider for Octavia, which means that the load balancers are defined in logic flows within OVN. So I don't need a whole VM, like an Amphora VM, and then running HA proxy to do my load balancing. It can just be done from the OVN layer. So what we're going to do today is I've destroyed my cluster and I've kicked off another deployment. So we just needed to make sure we meet these prerequisites, like making sure our quotas are all big enough for security groups, compute, etc. Configure Neutron. Neutron needs to have trunk ports enabled. We need to deploy Octavia on our overcloud, which we have documentation for here in TripleO, so deploying Octavia in the overcloud. The only thing you need to do here is either build the Octavia Amphora image, which we have documentation for upstream. So you could build this from Ubuntu or CentOS or whatever you want to do following that documentation. In my case, I've just downloaded the Amphora RPM from the Red Hat customer portal, and I've just extracted the QCOW2 and uploaded that as my Amphora image. But basically just follow the documentation. You just need to include an environment file in your overcloud deployment. It's fairly straightforward, and we've done enough overcloud deployments that I didn't want to keep rehashing the same thing over and over again. And if you are creating your own image, just upload it to Glance. So why do we need to do that? I just spoke about OVN. So the very first load balancer that's created as part of the deployment will be an Amphora load balancer, just the very first one. So that's for the API ingress traffic. And then every other load balancer after that will be using the OVN provider. So we go back to my terminal here. I've got a deployment running at the moment. I first hit that issue where I didn't have Amphora, and I saw that the first load balancer wanted the Amphora image. So I looked into it. It is actually mentioned in the documentation. I just didn't read far enough. So I've uploaded the Amphora image. I'm rerunning the deployment, and we can see the API has now come up, and now it's waiting for Bootstrap to complete. So if we go over to this tab and we check our load balancer list, we don't have the load balancer created yet, so we're not far enough along in the process for it to be creating our load balancers. So I'm just going to wait for this to complete. If this works, I'm going to destroy the cluster, and then I'll start again. We'll go over the install config file and what needs to change, and we'll start the whole deployment process from scratch. But basically, what we're doing is we just need to change the network type from OVN Kubernetes, which is the default in 4.6, to Kuryr, and then we need to add Octavia support and trunk support. And that's basically it. Then we just run the cluster create and wait for it to complete, and that's kind of where I am right now. So I'm going to pause this video. If I've got no further issues that need debugging, then we will just destroy this cluster and we'll start again, and I'll run through everything that I've had to do to get it working, and we'll discuss it from there. So my objective of this is to really do a deep dive into how that integration between Kuryr and Neutron works, how the ports work, how the trunks work, what it looks like on the hypervisors in OpenStack, how those VMs plug in, just so that we have a really good understanding of the feasibility of Kuryr, and hopefully at the end of this video you are able to make a more informed decision about whether Kuryr is suitable for you or whether you'd prefer to stick with OVN Kubernetes. So we'll wait for my deployment to complete, and we'll come back and discuss what we need to do it from scratch. Okay, so we're going to redeploy this cluster now, so I'll walk through everything we need to do. So the first thing we're going to do is just make a new directory for where all the information about this cluster is going to be stored. And the next thing we want to do is copy our install config into that directory. So the install config is just created with the OpenShift install. So something like that command there, and that will go through a bunch of prompts, and we can have a quick look at it. So basically prompts, we choose the SSH key, we choose our platform, which project on the platform, what's our external network, so where the floating IPs come from, which floating IP do we want to use, so this will list floating IPs in the pool, what flavor do we want to use, the base domain, so in my case BNE shift net, OKD4, paste in our pool secret, so paste in our pool secret, and then it generates our install config. So that's now in the test demo directory. Okay, so that's what we start off with as a default. Now we want to go through here and we want to change our network type. So that's going to become Kuryr. Then down here, we want to include Octavia support is true and trunk support is true. And the other thing I like to do here is just add an ingress VIP as well. So we do add ingress floating IP, and we spell it correctly. So for me in my environment, I use that IP address. So once we've made those changes, we can save that file, and then we just want to run the deployment. So just to show that the one I'm actually going to use is the same. There it is there. So the other thing we could do is we could create the manifest, so render all the manifests that we're going to use to create that cluster, and that gives us a bit more flexibility with understanding exactly what's being created. So to do that, we can do OpenShift install, and if we just do help, we'll have a look at the options. So we want to create in this case, so we'll do create and then help again. So here we can choose what we want to do. So we can create the ignition configs in the manifest. So I want to create the manifest. Okay, so that's going to render all of the manifests that will be used to actually create our cluster. So when I say manifest, I'm referring to like the manifest for the cluster operators, the services that will be deployed. We'll go in and we'll have a look. So we have a look in the manifest directory. We can see here that we have like the cluster network operator CRD, for example. So we'll have a look at this one. So that's creating our custom resource definition for the network cluster operator, etc. And this just gives us a little bit more of an overview of what we're actually deploying. It can be useful if it fails at some point. You can go in and have a look at that manifest, see what it is, what it's trying to do, and that gives you a bit of a better idea of why it might be failing. And if we wanted to make customizations to the cluster, we could do that by editing these manifests right now, because these are the ones that will be deployed. But at this stage, we're just going to go ahead and we're going to create the cluster. So we point it to that directory and we use log level debug so that we get all the information possible. Back directory. So now we basically just wait. Once the bootstrap node is up, we can export the kubeconfig file. And at that point, we can query the Kubernetes API and get information about the cluster, like OC get CO to see what cluster operators are deployed, or OC get nodes to see which nodes have been provisioned. But I'll pause the video and we'll come back at that point once we can communicate with the API. And I will just talk through what we could do at that point to do any debugging if required. And at that point, we'll also log into the bootstrap node to see what's happening. Okay, so that's reporting that our API is up now. So if we go to another tab, we'll just clear this and we'll export kubeconf. So we're going to export our kubeconfig from that directory that we just created, and we'll do OC get CO. So we can see now that the API is actually responding. So now what's going to happen is the bootstrap node is going to create the masters. So we do OC get nodes. We can't see any nodes just yet. So the bootstrap node will create our masters, and it will host the kube API in the meantime while those masters are created. At that point, it will move the VIP, so the 10.0.0.7, over to the newly created master nodes, and the master nodes will take over from there. So at that point, the rest of these cluster operators will come alive. Now, if we have a look at the OpenStack dashboard, we can see that our bootstrap node has an IP address here of 172.20.10.60, and we can see our masters have been created. So what we can do is we can go to my desktop PC, which is the one that has the SSH key for the core user. It's the one we included in our install config YAML. And we can see we're able to log into the bootstrap node now. So we just do a journalctl-f. And we just follow along here. We can see everything that's happening. So it's just going to go through and it's going to create all of those manifests that we talked about to define everything that needs to be defined, just to the point where it can create our masters and hand control over to the master nodes. The master nodes will create the rest of the cluster operators, spawn the CNI pods, etc., etc. And then the master nodes will create our worker nodes and add them to the cluster, which is when the installation will finish. Now, because I'm in Australia, I have horrible internet, so my deployment from the actual deployment script will probably time out. But at that point, the installer doesn't actually do anything. Like, everything now happens from the bootstrap nodes. So when this times out, which it inevitably will, we can just run OpenShift install, wait for install-complete, point it to that directory, and it'll just keep going with what it was doing before, just so we can report on it. But once those masters are up, we've really completed the deployment at that stage. We can just troubleshoot it like we would any normal OpenShift or Kubernetes deployment at that stage. So once our three control plane nodes have become active, then they will be in not ready status while the CNI initializes, and that gets created by the network cluster operator. So what we can do is just follow along with the status of the network cluster operator. So we go back to this tab here, get CO. So the only one that's created at the moment is cloud credentials. This is going to initialize the connection with OpenStack so that it can check on various things, create VMs, create load balancers, etc. And we'll see in a minute the network cluster operator will become active once those three master nodes are up and running. So once we've logged into the bootstrap node, we can just follow along here and get an idea of where it's up to. Like, it gives us that command at the very start when we log into this system. It gives us this command here that we can run, and this will print information about, like, more specifically where it's up to. And you can see there the 99 OpenShift cluster API worker machine set.yaml. That's one of the YAMLs that we saw previously. So while we're waiting for those to provision, let's just check out what other resources we have. So if we do our OC get machines-a, so we can see there that the three master nodes have been provisioned, which we verified by looking in the OpenStack dashboard. Okay, so we can see here, at some point you're going to go from having no nodes when you type OC get nodes to having your three master nodes or control plane nodes. So we do our OC get PO-A now. We can see that some of these containers are now creating, and the most important one here that we want to keep an eye on is our network operator, because it's going to be in charge of creating our CNI, and those nodes need the CNI before they're going to report as ready. So let's keep an eye here on our network operator, and we'll see how it goes. We can do an OC get events on that namespace, which is OpenShift network operator. So we can see it's pulling it. Again, we just have to wait for the dodgy internet to allow it to download that container. And once that pod has started, then we'll see our network operator here report that it's degraded, and then we can follow along with the sequence of events that happens after that to initialize our Kuryr CNI. Okay, so it's now transitioned to running, so we do OC get CO. We can see it reports in our cluster operator section. So now if we follow along with the logs from our network operator, in the network operator namespace, so we can see here that it's done a few things. So we've created the networks. So it's ensuring that the services network is present with our 172.30.0.0/15 CIDR. It creates the subnet pools. It checks some worker nodes are on those subnets. It checks for our router, checks for the security groups that are used by our master and worker nodes. It checks that the security groups are allowing traffic, and it creates a OpenShift load balancer. So if we have a look at our load balancer list now, I have two here that already exist, so we'll ignore those. We can see we have a pending create one here, and it's using the Amphora provider. So if we do OpenStack server list -- all, we can see up the top, we now have a Amphora VM created actually, it's already running. So we'll do that load balancer list again. We will expect to see this load balancer go into an active state here in a minute. There we go. So now we're active. So it's provisioned the first load balancer that will be used for our API ingress. So let's check CO again. Okay, so we've got a bunch of pods that are now running. So the next thing we're going to expect to happen here is the OpenShift Kuryr namespace is going to be created. So let's just follow along with the logs from our network operator again. Okay, so we can see here it's saying that the daemon sets aren't available yet. So we know that this operator is going to start creating our CNIs for us. PO-A. So when we come back, we can now see that the Kuryr namespace exists, and it's starting to deploy some of the resources required for our CNI. So we do OC get all on that namespace. We can see we now got the deployment, which has created our daemon sets, which is now deploying our pods. So we can just do get events to see what's happening. So again, just pulling an image at the moment. There's going to be a lot of cuts in this video because everything is so slow. So I'm just going to cut out some of the blank and boring spaces. And this is what I was talking about with the installers going to fail because it takes too long. So we can see here that it's failed, but if we do a wait for, so OpenShift install, wait for, install complete, point it to that directory and then -- debug, it's just going to keep waiting for it to happen. And I'm going to need to do this multiple times. It's just the reality. So it's going to wait another 40 minutes. We can see that it's 71% complete. We go back over here, get CO. Okay, so we've made a bit of progress here, but we're still just waiting for our pods here to be running. Once these are running, everything else will start progressing because our control plane nodes will move into a ready state, which means they can now have pods hosted on them, and the rest of these operators will be created from there. One of those will be the machine operator, and it will provision our worker nodes and add them to the cluster, and that will allow everything else to be created from that point. So at the moment, we all just hinge on this CNI. Okay, so 7 minutes, we've got our CNI up and running. Do OC get CO, and we can see now that it's still progressing, but now we have the version information available, and it looks more like what you would expect from a cluster operator at this stage. If we do OC get nodes, we can see that now that the CNI is present, the nodes are reporting as ready. And if this didn't happen, if they didn't go into ready state, you can still do an OC debug node and then the node you want to do a debug on. And that'll allow you to log into it. You can chroot to /host and do some troubleshooting, like maybe you want to follow along with the kubelet log, so journal ctl-f-u kubelet, and that will tell you why it's not initializing. And if the CNI is not deployed, then kubelet's going to say, is your CNI deployed yet? I can't find a CNI. That's basically the problem. So we do OC get PO-A, and we can see we have a whole bunch more containers creating now. So this is just the rest of our cluster operators, everything else we need to deploy the cluster. If we do OC get machines, so still just the master machines defined, it hasn't created the workers yet, but if we do our OC get machine set, we can see that we do have them here. So what we're looking for is our machine API controller, and we can then follow along with the logs there once it's created, and that'll show us it creating the worker VMs in OpenStack. And we can check at that point with OpenStack to make sure they come up, there's no errors creating those VMs or anything, like we didn't run out of resources or whatever the problem might be from the OpenStack side. So at the moment, I mean, it's just a waiting game. We need to wait for all of these containers to download again. So I'll cut here again and we'll come back as we progress a bit further. Okay, so in the end, I ended up deploying OpenShift 4.7. I had some issues with Fedora CoreOS starting the etcd containers. Now, I did some debugging for a little while, but ultimately I just wanted to finish off this video. So I've just done all the same steps we talked about, just using the OpenShift 4.7 installer instead of OKD. And we can see that now it's up and running on 4.7, which has just been released. I do have an issue with the console here, which seems to be a DNS problem, but I'm just going to ignore that. The main part of this is for the OpenStack side and the integration with Kuryr. So if we have a look from the OpenShift side, we do OC get svc-a. We can see we have a whole bunch of services here. And if we go back to the OpenStack side, we do OpenStack load balancer list. We can see what that's done is it's created a bunch of load balancers. So these load balancers represent our services. So we take a random IP address here and we go back over to OpenShift, grep for that IP address. We can see that that particular IP address is the cluster IP for Prometheus. So any pods that need to talk to Prometheus are going to talk to that service, and that service is actually an OpenStack port connected to a load balancer. So we do OpenStack port list and we grep for that same IP address. There we go. We can see it's here. It's assigned to this subnet. We can see it's assigned the name OVN LB VIP for that UID. So basically how this works is that these ports exist on trunk ports. So we do OpenStack network trunk list. We can see we have a few trunks there, and we've got one trunk per node in my cluster. We are back here. So these are the nodes I have. Get rid of the Y, that's a bit messy. So we can see I've got 3 control plane nodes, 3 worker nodes, and then we can see I have corresponding trunks for those nodes over here. So if we do a OpenStack network trunk show on one of these, what we'll see is we actually have subports under that trunk. And each of these have VLANs assigned to them. So what happens is, just like a normal trunk on your switch, we would connect this port to our worker VM in this case, so worker 0 MJJ-V6. And then on top of that trunk port, we're going to trunk all of these VLANs. And these VLANs are just for the pods that run on those networks. So we'll do more of a deep dive to that probably in a bigger series about Kuryr, because it's quite a big topic and we're going to need to delve into OVN and various layers to look at how all this comes together. But let's focus just on the load balancers at the moment, because it's one of the key defining factors of Kuryr is that every service creates a corresponding load balancer in OpenStack. So as we saw before with the load balancer list, we have quite a few. Now, if we look at the provider type on these, we can see that the provider is OVN. So I might just filter this and make it a little bit easier to see. So we'll do load balancer list, provider, VIP. So this information here is a little bit easier to see now. So we can see that the majority of these are created using the OVN provider, but we do have this one here which is using Amphora. Now this one is actually created before Kuryr even exists in the environment. It's created by the cluster network operator. So it reaches out to the OpenStack environment and provisions the very first load balancer that will be used. And that just so happens to be created with Amphora because of the way the network operator interacts with the cloud provider of OpenStack. Once Kuryr exists, Kuryr is aware of the OVN provider and it's able to create the remaining OVN load balancers. So there's quite a few there. So let's take a look at how that looks from the OVN side. So we go to our controller and we look at the LB list in OVN. So we want to look at the northbound database. So we do OVN NBCTL. And we do LB-list, which is load balancer list. So we're execing into, in this case, our OVN controller container. So we can see here that the same load balancers that we just saw from the OpenStack Neutron API call that I made are being returned from OVN, and this is what they look like in OVN. Let me just go to the top here. What we can see is that we have the VIPs. So these are the VIPs that we looked at before, and these are the pods they're connecting to on the back end. So we take, for example, this one, and we go back to OpenShift. So what we can see there is that IP address is used for a lot of nodes. So I think that's actually the IP address for our master, and we can confirm by doing wide. Yeah, so we can see it's here for master one, which makes sense. So let's get a different example from OVN. Let's try this one here. Okay, that's a bit better. That's just one pod. So that particular load balancer is taking the service for Grafana and is pointing it to this pod in the back end. So let's take another look from the OVN side at that one we just looked at. So here it is here. So the front end VIP is going to be 172.30.148.189. The back end container will be the 10.128.57.183. So if we check the service, well, let's just get everything from that namespace so that we have a clear understanding. But this IP address should be our SVC. Okay, so here's everything from that namespace. And the IP address we were looking for is 172.30.148.189. We go up a little bit. We can see that here is our service for Grafana. So let's dig a little bit deeper into that. Okay, so this is our SVC for Grafana. So it looks just like a normal SVC. There's nothing that really stands out here. In previous versions of Kuryr, we would have annotated the resource for the service to let it know about all the information for the load balancer. So those load balancers we saw previously, they were defined using annotations on the services, and the service would have all the information about the OpenStack load balancer. In 4.6 and 4.7, we moved that to a custom resource definition, and we can see by doing OC get Kuryr load balancer in all the namespaces, we get a list of all of those load balancers again. So the load balancer we want to look at is the Grafana one. So we run oc get kuryrloadbalancer -o YAML because I want to see the YAML output for how it's defined. Grafana, and we're going to the OpenShift monitoring namespace. So we can see under the status section, we have all the information that is used to configure the load balancer from the OpenStack side. So for example, the listener's ID here. So we could take this listener's ID back to the OpenStack side and do OpenStack load balancer listener show on that ID, and that's going to be a valid ID for the OpenStack side. So we can see there we get the output. So this keeps track of what resources should exist on the OpenStack side. So I might leave this video there. We might just do a real quick recap, and I'll make this a bigger series, and we'll deep dive into how Kuryr works and all the inner workings of how it interacts with OpenStack. I think as I started to get into this, I realized this is more of a topic than just a single video. So let's just do a recap of the installation process. So the first thing we want to do is we want to create our install config file, and this is done using the create install config command, just like that. We're going to go through, answer all the questions, paste in our pull secret if we have one. Then we're going to edit that install config file. And in here, we want to just make a couple of changes. So yours will have the pull secret and your SSH key. I've just removed them from this file for the video. So the first thing we want to do is we want to add trunk support and Octavia support under the platform OpenStack section. We need to change our network type to Kuryr. So that will be, if you're using OKD, it'll be OVN Kubernetes. If you're using OpenShift, it'll be OpenShift SDN. And then in my case, I just like to add the ingress floating IP as well. It just saves me doing it manually after the deployment is completed. And obviously just change your node counts, whatever you want. In my case, I just left it as defaults, but maybe you want 2 workers and 3 masters, whatever it might be. Just change that to suit your requirements. Then we run the create cluster command. So what I do is I create the install config.yaml file, and then I create a directory where I'm going to do the deployment from and copy that install config YAML in there. So I don't have to do the create install config every time. I can just copy over the install config into the new directory and rerun the cluster create. It just saves some time. So that's going to go through and that's going to create your cluster, and it'll pop up at some point and say the API is active. Once the API is active, you can just export the kubeconfig file. So that will be in the directory. You can see there that it's in my BNE shift auth kubeconfig. Then you can do OC get PO-A, for example, and you'll see all the pods as they're starting up. The nodes and stuff will be empty until your bootstrap process is complete and the bootstrap nodes hands over control to the 3 master nodes, but you'll eventually start to see it all become available. If the install script times out, like it does in my case, because my internet is just too slow to pull it all in 30 minutes, you can just do wait for. So you can do wait for bootstrap complete, for example, and that's just going to start it from where it dropped out. In my case, it always fails just after the API comes out while it's waiting 30 minutes for the bootstrap process to complete. So you can just start it again, just wait for bootstrap complete, and that will just keep printing the same things it was printing before it timed out. There's no reliance anymore on this install script. All it does is uses Terraform to create the initial resources, and then control is handed over to your bootstrap node initially. That passes over to your master nodes and they will create the worker nodes from there. Once it comes up, you'll be able to see all those load balancers as I showed you back on the OpenStack side. So we go back to the OpenStack side and do OpenStack load balancer list. You'll be able to see a bunch of load balancers there. The first one you'll see will be created when the network cluster operator is created. So if you do OC get CO, once you see the network cluster operator come online and do OC get PO-A, you'll see the network cluster operator appear and creating, container creating and then running. Once it's running, it'll create your Amphora load balancer, which by default will be 172.30.0.1. That will then provision your CNI containers, which is for Kuryr, and Kuryr will create the remainder of the load balancers. And as I said, we'll do a deep dive another time, but we can go over to our controller node do podman exec IT into the OVN controller container, OVN NBCTL LB list, and that will give us that list of load balancers. And then you're good from there. You can start deploying your applications and workloads and start utilizing OpenShift as you would with any other CNI. It's all basically exactly the same at this point. Just keep in mind though that when you're creating services, it's going to create those Kuryr load balancer resources. So OC get. So it'll start to create the Kuryr load balancer resources, and that's what controls the OpenStack side of things. So when you launch a service, it will then create the rest of that automatically. So if you needed to troubleshoot, you would first check that this exists, check the load balancer exists on the OpenStack side, maybe do some curls to the load balancer VIP to see if it's working. So I hope that's a good intro into how to install it. And in the rest of this series, I'll make a new playlist for it. We'll deep dive into how those ports that we saw on the OpenStack side and the trunk ports go into the VMs, and then how the VMs use the VLAN tagging within the pods to send that traffic to the trunk and across the trunk, and et cetera, et cetera. We'll do a big deep dive into that and we'll explain it in a lot of detail. Hopefully that's helpful, and I'll see you in the next video.